Hello, this is Mr. Kent of MrKent.com, and after putting up some information on how to charge batteries with a balanced charger and measuring my voltages and so forth on the battery that I had crashed with my Bebop, then I had some questions that on how to use a balanced charger. So that's what I'm going to do with this video, is to eventually go through how to use a balanced charger. But in order to use a balanced charger intelligently, I thought, well, I used to teach electronics, so let me give you a real quick electronic lesson, and then we'll get into the balanced charger. First of all, electronic has to do with electrons. And if we look over here on the right side of this page, an atom has a bunch of protons, or one, but anyway, one or more protons in the center, and it's got, excuse me, I've got a hoarse throat. Anyway, and then on the outside, going around the atom at the speed of light, if you can imagine that, something so small that you can't see, traveling at the speed of light in a circle. A lot of energy there. Anyway, so the electrons have a negative charge, okay? And so when you have an atom, you have a positive charge in the middle, and these babies in the middle are heavy and they don't want to move, but the electrons are very, very light objects as far as mass concerned. So they move away from the atom easily, and when they do move away, they become, this thing is no longer called an atom, but it's called an ion. So when it loses electrons. But in the normal state, every atom in everything around us, including those that make up our bodies, every atom has the same structure. It's just that different elements are made of atoms with different numbers of protons and always an equal number of electrons going around the outside. And there's more than one ring out there, okay? So that's basically an atom. And when you have electricity, you're pulling these electrons away from the proton, and the electrons then go down a wire. And let's go over to this side over here. And this would be a typical battery. And a typical battery has two parts to it. It has a part that is usually metal, and metal has electrons that move around or can leave. It's kind of like, well, let me show you with this wire here, okay? This is a non-conductive material. It's plastic. And non-conductive materials have atoms that will not allow their electrons to leave. It's kind of like when God created the atoms, he said, now, you guys, when you go to school today, don't share your lunch with anybody. You keep everything to yourself, and you'll be real, you won't get germs and so forth. And then God said to the metal parts, the metal that usually is what we use as conductors, he said, when you guys go to school, you take those electrons with you, but if somebody needs an electron, give it to them. Don't be stingy, share those electrons. So that's the way the world is made. So we have some atoms that are non-conductors. They hang on to their electrons, and there are some atoms that just love to get rid of their electrons and share them with everybody. So in a battery, when we have a battery, we have generally a metal part, and then what's called an electrolyte, which can be liquid or a paste of some kind, sometimes a different kind of metal. And so the long lines in the symbol here represent the electrolyte, and the short lines represent the metal. And the reason they call it battery is because there's more than one of these in a battery, but that's how it was originally called. It's actually called a cell. Okay, now, so like I said, metal is usually willing to give up electrons. And so when you put the metal and the electrolyte together, generally there's a chemical reaction between the two, and so the electrolyte steals the electrons from the metal, and then it gets so many electrons that it has more electrons than it has protons. So then the electrons remember, they have a negative charge, so now they're pushing on this wire, And over here, the metal says, hey man, I'm all out of electrons. I need some electrons. So he's got a positive center charge, so he's drawing electrons. Now, in an electrical circuit, we have some kind of a load. It might be a light bulb, might be a motor, and it might be a whole bunch of different things. But when we hook up electricity to it, well, then that current comes down through here and goes around here and comes back up here and makes a circle traveling at the speed of light. And this load actually creates a resistance to those electrons flowing through. So that's a basic electrical circuit, and like this would be the motors on your bebop drone. And if there's no resistance, if we draw a line, if we short something out over here, okay, now there's no resistance. Now the current in this circuit is going to go so much higher because there's nothing to stop the flow. When that happens, this battery is going to get real hot because of the electrical chemical changes that are going on, and it gets really hot. Now, one of the things to keep in mind that is in a circuit like this, the maximum amount of current depends on the size of these plates. And so the current is regulated by that plus whatever the resistance is, and the resistance can vary and so forth. Now, so that's a basic electrical circuit. One of the things that I'll show you here is I have taken a, you might be able to see the vinegar that I put in this pop can, okay? Vinegar is an acid. And so if we take my voltmeter, and we'll lay it right next to it here, and we'll turn it on, and it's on 20 volts. It's set to 20 volts. And this insulator here, I'm going to stick down into the can, and hopefully I can't let it touch the side. So hopefully that's just, make sure here. I can always lift it up. All right, so I'm going to push. I'm going to contact the can with the positive lead, and you can see that on the meter it's showing 5.1 volts. So, I'm sorry, 0.51 volts, about a half a volt. We can get about a half a volt out of a pop can with vinegar in it, white vinegar. And that's how batteries work. In your automobile, if you take the little caps off of the cell and take your voltmeter out there and put the red lead on the positive post and the get it scratched. I got to scratch through the paint, and dip your black lead into the acid in the battery. You'll get the same result. So that's a simple illustration of how a battery works. And what happens is when that is sitting there like that, I won't get into too much detail, but when that's sitting there like that, the acid is eating away on the aluminum, and in the process of the chemical reaction, then it generates a voltage between a difference in voltage. And that's because what's going on is, I put this down in my acid I spilled. Anyway, what's going on is the liquid is the long line here, and the pop can is the short line. And so when they get together and the acid starts working on the aluminum, it creates a chemical reaction and generates that voltage. So that's how a battery works. But a battery doesn't have to have liquid. It can have paste or anything that is generally is like salt water would work, but it's got to be acidic. Now, we'll take this and we'll put it here. And so what is this all about? Well, in the LiPo battery, Li is for lithium. So you have lithium, and where's my, okay, so here we go back to here. Lithium is the short piece. It's the metal, all right? And then when they make a LiPo battery, they run two sheets. They run a sheet of lithium, a very thin sheet, and then they run a sheet of what they call polymer. Now, polymer is just plastic, okay? And there's all kinds of different plastics, and they can create a plastic that will, not all plastics are insulators, and some are better than others, but they can create a plastic that is not necessarily an insulator. So when they put that plastic, which has an acidic construction to it, when they put the plastic next to the lithium, it generates a voltage. And that voltage, and I won't go into big details, but anyway, when it gets up to a voltage of about 3.7 volts, then the lithium says, that's all I'm going to give you, and the polymer or the plastic says, that's all I want anyway, I'm happy. So let's take a look. This would be a lithium atom, okay? And you'll notice it has 3 protons and 3 electrons. Now, if you know anything about chemistry, you know that this is not a stable situation. Anytime an atom has, the first ring should have 2, and the next ring should have 8, and it goes on. And that's just, if it has those numbers, it's stable. It becomes a good insulator. But in this particular case, this is not a good insulator because we need to have 8 electrons to make this stable material. So this is sitting here saying, the lithium atom is saying, hey man, I got stuff I don't want. If anybody wants this, I'll share it with them. And over here is our polymer, and I don't know how many electrons it has. We can look at. You can go to the internet and Google it. How many? Well, first of all, you'd have to go to Wikipedia and find out what the name of the plastic is, or the polymer. So anyway, it's over here, and it says, you know what? I could use 1 more electron. So when we put these 2 next to each other, then this guy comes over here, spins with these guys. The lithium says, I'm happy, and the polymer says, I'm happy. And so now we have a battery that has generated 3.7 volts, just like my pop can battery generated 0.5 volts. And so we come over here now, and of course, remember now, there's trillions and trillions and trillions and quadrillions of these in just a short, little, small place. I mean, the atoms, there's so many atoms that you can't see through them, you know. Anyway, so there's so many of these that there's plenty to spare, and there's a lot of atoms of polymer. They're saying, hey guys, I missed out. Can I have one? And there's a lot of atoms of lithium saying, hey, I got an electron. Anybody want it? But once it gets up to 3.7 volts, then the whole thing stops. Just like my pop can. When it gets to 0.5 volts, everything is happy. All right? So now, when we start discharging this, in other words, when we start the motors on our drone by throwing the switch, and then this current starts going over this direction, goes through the motor, and goes out this side. So pretty soon, what's going to happen is this situation here, which can be charged up to about 4.2 volts, gets over to this situation here. And so now we're down to about 3 volts on this thing here. And so it says, hey, I don't have any more extra atoms to give you. I've sent them all over to the polymer. And the lithium says that. It says, I've sent them all over to the polymer. And the polymer says, come on, man, they're wanting some more. And lithium says, I'm sorry, I'm exhausted. So what we do then is we take that battery and we connect it to our charger. And what the charger does is the charger forces the current back this direction. I guess you'd say that's not really that's not the circuit, but the charger forces the current the opposite direction as when you were discharging. So what it does is it takes these electrons that are over here and sticks them back over here, and sticks them back and forces them back, because it puts a voltage. This charger is putting a voltage into this circuit that's forcing them all back, and it'll force it back if you have a good charger until the cell gets up to about 4.2 volts. When it gets up to about 4.2 volts, then you want to stop charging the lithium battery, because if you go any higher, then you start generating the electrolyte, the polymer starts to get hot and starts to generate gas. And so parts of let's say if we had a square of polymer, then as it gets overheated, well then like there's a bad spot, there's a bad spot, there's a bad spot. Now we don't have the current capacity that we did have because we're losing pieces of our polymer. It turns into gas. Now, if you've ever noticed an old used LiPo battery, if you can, they're covered up inside the Bebop battery, but they get puffy. And the reason they get puffy is because they've been overcharged or they've been run down below the 3 volts. And the LiPo battery is real critical. It has to remain between 3 volts and 4.2 volts, and it'll work fine. So, and if you want to neutralize it, you want to stop it when it's at 3.7. So that's basically how that works. Now, then let's go over here to one of our LiPo batteries. I got this off the internet. One of our LiPo batteries that has 3 cells, and that will give us in a neutral position, that will give us 11.1 volts. 3 point, what was it, 3.7, 3.7, 3.7, and 3.7 add up to 11.1. And so this is when the battery is new, the positive connection comes out and the negative connection comes out, and it's just these 2 connections that run your Bebop. These connections here don't run the Bebop. But when you put it on the charger, well then it reverses the current. It hooks a positive charge up here and a negative charge here. So now the current is going to go the opposite direction from when it was running, and all of those lithium cells are going to get their electron back. And when it's all charged up, if you go, what is it? Oh, let me see. Where's my paper at? I don't have it laying. Oh, there it is right there. Anyway, if you charge it up so that the cell gets to this cell is 4.2, this cell is 4.2, this cell is 4.2, and that's as far as you want to charge it, then the battery is charged up, and you have 12.6 volts somewhere in that area. So here's the thing. When we have, like when you get your battery from Parrot, I don't know if it has anything like this built into it. Because what happens is not all of these cells are equal. Let's say this cell is weak. And this cell is strong. And this cell is just normal. Okay, we'll say normal. Okay? I wish I was normal, but I'm not. Now, when you run the battery, well, here's what's going on. When you run your battery in your Bebop, first of all, the Bebop is saying, hey, I want electrons. Give me some electrons. Give me some electrons. So it's pulling current here. And what happens is it pulls out of this cell, and then this cell's connected up to this cell, so it's pulling out of there, and this cell is connected up to this cell. That's called a series circuit. They're in series. And then this cell is pulling it out of the battery, okay? Now, that's when you're running it, okay? And what happens is a strong cell will stay charged longer than a weak cell. This cell, we'll make it look like here. The level is, let's just say, well, let's make it this way. The level is going down faster than it is in this cell. And in a normal cell, it's going down at this rate. But this cell here is weak, so it's discharging rapidly, and it's all working fine. But because you have a weak cell, pretty soon it's down to where it doesn't have much left. So now instead of having 12.4 volts, you're down to where now the battery's going down, and you've got less and less percent, and that's showing up on your screen of your Free Flight Pro. So then you take it out and you put it on the. If you put it on the, I looked all over the internet for a schematic of the Parrot battery schematic, inside the battery, the diagram, and I couldn't find a thing. So I really don't know what they've got inside there. But it charges as if this wasn't there. Because what's going to happen is when you start charging this and you start running current the opposite direction, okay? So the strong cell is going to say, I'm going to fight that. And then the weak cell is going to say, oh, no, I'm not going to fight it. And so the weak cell then, it fills up pretty fast. And then the normal cell, it's filling up. But the good strong cell, pretty soon it gets up to where the bebop charger says, hey, it's getting pretty close to 12.4. I'm going to shut it down. And this cell, the strong cell, never got all the way charged up. Okay? And so then you keep using it and you keep using it. By the way, the best way to keep a balanced battery is charge it down to like about 15% before you quit. Don't charge it down to to 60 or 70% and then charge it again, because it's easy for them to get out of balance. But if you bring them all down so they're all low, then it's about the same thing as balancing all of those batteries. So what's going to happen then is with the Parrot Bebop charger, it seems like this one doesn't get charged up, and maybe this one gets all the way charged up and maybe even overcharged. And then this one, it gets normal charge, and pretty soon it's up to what it should be. And so the Bebop charger detects that, and the best way to detect it is by how much current's going through it. But I don't know I don't know what their schematic is. Okay, so then pretty soon you've got a battery that is pretty weak, and it's over a period of time, if you keep using the Bebop charger, your battery, you get the flashing red light. So if you have a balanced charger, you have this little computer here. Okay, this computer right here says, all right, so first of all, we're going to do it like the Parrot charger does. We're just going to charge it up, and when it gets close to where this cell is here and this cell is almost to be overcharged, because this computer over here is monitoring the voltage on each one of these cells, okay? And so it monitors the voltage between these two and the voltage between these two and the voltage between these two, all right? When this one charges so fast, when it gets to, well, we'll just say 12, okay? When it gets to 12, or 12, we'll say 12. Well, we'll just say 12, make it easy. Then it notices that this one is only at, let's say it's only at 11.8, okay? And this one is going up, and it's somewhere in between there. So then what the balanced charger does, a good balanced charger says, all right, I'm not going to charge this one anymore. In fact, and by the way, this is happening at a high rate of speed, and it checks it, charges, checks it, charges, checks it, charges. And so it sometimes even discharges this to keep it from going over. But in the meantime, it's charging this heavily, because the computer's sending it's controlling the current through these wires, and the normal one, whatever it gets to. But what a balanced charger will do, by monitoring and charging or discharging, it will not turn off until every one of these is balanced. And so that means that the weak cell is at 12, we'll say, at 4.2. The strong cell is at 4.2, and the normal cell is at 4.2. When the computer over here detects that, then the computer says, turn the whole thing off. And so now your battery is charged and is balanced. That's basically how a balanced charger works on your LiPo battery. Now, the next thing I'm going to do is I'm going to set up my balanced charger, and we will proceed and take a look at how to use a balanced charger. So stay tuned. All right, this is my new charger I got, because when I was making my last video using my other charger, between then and now, it bit the dust. So I bought me a new one, and I got this off of Amazon for $54. Now you can buy them cheaper, and if you have a power supply that'll run somewhere between 10 and, or I guess it says 11 and 18 volts, then you wouldn't have to buy this, and you can get them for, I think, as low as $27. But I'm not sure the $27 ones come with all the plugs, so I would look closely if you're going to go buy one. Or you can go to the hobby shop. Local hobby shop is the best place to go because it supports the hobby, and they have what you need. And the nice thing about going to the hobby shop, if you get it home and there's something wrong with it, it doesn't work, you don't have to wait 3 or 4 days or 5 days or 2 weeks to get it exchanged. So that's a good way to go. All right. So anyway, if you're going to get one, then I would, if you haven't got a charger, a power supply, I'd go ahead and get one. Now, I think you can get them for about $33 that have everything. They just don't have as many options and doesn't handle as much current. Basically, all the different companies that use the guts on the inside that come from China, they just put their name on it, and then there's different levels of current and so forth, different options. So what we're going to do, let me see, I'm going to take a pause here for just a minute, and we're going to put something under this so you can see it better, and me too. All right, I put a little eraser underneath of this thing so it'll be at an angle. Hopefully it still works so that it doesn't reflect light all over the place. Let me see what my camera is showing me. All right, well, let's just go ahead and turn this on and see if we can read it. I think it's going to work out okay. Okay. Let me get set back down here. So when you turn it on, it might say user set or it might say program select. User set is for you select the things that you want in the program. For instance, if we hit, now this is the enter key over here. This button right here is like an enter key. It says start. If we hit that, that takes us into where we can make adjustments. For instance, the voltage of your type battery, LiPo, it should be 3.7, but you can go adjust that, okay? And then we can go through all of the different things by hitting the advanced button, and the 60 minutes and all this, the sensitivity, charge and discharge, waste time 1 minute. Don't know what that means. I have to read the manual, and so forth. Capacity cutoff. Do I want the beeps on or off? I think I'll just leave it like it is, and it goes all over right around here. And now we're back to the beginning. So if you want to change those things, that's up to you. But actually, I would just leave them like they are. Okay, so that's user set. Now then, if we hit this one more time, we get to program select. In program select, we can go through and we can check. Program select, we can go through and let me see. We're going to hit this. No, we're going to hit this. Program select. Oh, okay. We'll hit the enter key. Okay, and if we go back, it said LiPo battery. So what we're going to do is we're working with a LiPo battery. I'm sorry, I just got this, so I'm a little confused here. So the other one had different instructions and stuff, but I'm not going to make excuses. All right, so we're going to go. We hit the enter key. We're going to charge a LiPo battery. All right. Now this is a battery that I've had for a long time. A good friend of mine gave it to me, and it was used when he gave it to me, and so it's getting old. And but we're going to use this as our guinea pig to charge the first item here. Put it on charge, you know. Anyway, okay. So let's say we want to charge this, and so we're going to hit the start button. And of course, we want to charge it. It's a 2.7 amp battery, or 2,700 milliamp hours. So we're going to have to increase that. So we go to the increase or decrease button. So we're going to go and hold it down until it gets to 2.7 amps. Okay, then we'll hit the start key, which is the enter key, and we'll choose that. All right. But this is a 3S battery, so we're going to have to increase it from 1S to 3S, and that'll give us 11.1 volts. So then what we can do is we're ready to go, so we'll hit the start. We've got to hold the start button down until it starts. All right? Just checking to make sure. Okay, here's the problem. I know. I don't have the battery hooked up. So what we're going to do is we're going to go over here. And I got to get, hang on a second. Not supposed to be a comedy. All right, so we are ready. This is the charging cable that I have made. I've got a video on how to make this. What you need to do is I'd go to Hirose Electronics, and there in the description I will put the name of this plug, which goes into the battery. I don't know which way it goes here. Yeah, okay, it goes into the battery, and then you hook it to one of these, and you can get these. You can get the Dean's plug and these things off of Amazon or at your local hobby store, because the hobby store is a good place to go. So you need these, and then you just find somebody, if you don't know how to solder, and find somebody how to solder that together. All right. So what we're going to do is we're going to plug that in to the battery, and then we're going to take our Dean's plug, and they put an insulator on that. That's a good thing. So get this turned around like so, and plug it together. And then this is a 4-prong, so we'll put it into the 4-prong. Now, when we hit the enter key, now it should work. So hold that down. It's checking the battery. Do I want to stop? No, I want to go. Okay, so now it's charging the battery, and if I hit the status key, you can see that it's almost charged up. Cell 1 has 4.2 volts, cell 2 has 4.2 volts, and cell 3 is a little weak, so it's charging cell 3, and it'll hold it there for a little while, and that's part of those settings that we were looking at. How long do you want it to hold and check? And it'll keep checking that until it gets up to they all stay at 4.2 volts. Okay, so but we're going to stop, because once it'll beep when it's charged up, but it's not necessarily balanced. So since we're still in the charge stage, all we have to do is hit the status to increase, and that'll take us to the balance stage. Now, is that going to be, yeah, that's still the same, 3S, 2.7 amps. And so now we're ready to balance it. So we hold this down. Confirm it. Go back over here. And now it's going to actually, the first time it would try to get it there, this will sit there for a long time, making sure that it's totally balanced. Okay, so that's the balance part. Now I'm going to try showing you something which I've never used before, but we're going to stop, and then we're going to go through the program, LiPo Battery, and we're going to go through all these things, and we're going to go to save data. All right, so we're going to press enter to save data. And now then, this is going to be, you can save 5 different battery settings. And so this is 3.7 volts, and that's not what I want. So we're going to go through here, and let's see, we're going to go, save data. Oh, I blew it. Okay, save data. And then we want to hit that, LiPo. And we want that to be I don't think that wants to be 12, so we want to turn that up. Whoa, that really went up fast. We want to get that down to 11.1. Okay, then we're going to hit this, and we're going to have it, we got to go to, that's 5 amps. We don't want 5 amps, so we're going to go back to, we're getting close. All right. Oh. Okay, 2700 milliamp hours, and now we're ready to save, so we'll hit enter and save it. Oh, we got to hold it down. I'm sorry. We got to hold it down. Oh, and it's, yeah, charge 11.1 volts, 3S, and we'll hold it down. Okay, now it's saved that. I'm not sure I know what I'm doing, so we're going to unplug it. And we're going to put it back on again, because I've never done this, but I thought I'm going to learn how to use this thing. All right. And we're on Program Select, so we're going to go ahead and hit, we're in LiPo Batteries, so we'll hit that. Yeah. And we don't want to charge. We're going to go through storage, discharge. Oh, you know what? We need to go, through this. Save data, we're going to go to load data, all right? So we'll hold that down, and that's number 1. And so now all we have to do is we have to select that, and now we're ready to go. We don't have to go through pushing the buttons every time. And then I've got some park flyers that use 2S batteries, so I can set them up to save that and then just switch between them when I'm using my different batteries. So that's how a balanced charger works. And of course, let's go through one more thing here. Let's see. Balancing we've talked about. Fast charge I would never use on a LiPo battery. Storage, this will bring it down to 3. Every cell will be at 3.7 volts, and it'll stop. But it'll make it so that sometimes you'll see a battery that's got it's all puffy because it's either been overcharged or over discharged. And if you leave it all charged up and sitting there for months, it will get puffy because it begins to deteriorate the electrolyte. So a better thing to do if you're not going to fly for a long time, like 2 or 3 months, put it on storage and get the voltage down to 3.7 volts per cell. So, and then there's discharge if you just want to discharge it, which sometimes comes in handy. Right now I'm not interested in that. So, and there's the charge. So there's the cycles, and I would recommend everybody gets a balanced charger. These are not too expensive. This is at Hirose Electronics. I think that thing costs about $4 or $5, something like that. Different places like Digikey had them for $3, but I think the price has gone up since everybody wants them for their bebop chargers. So anyway, there you go. That's how to use a balanced charger. I hope this has been helpful. I want to thank you for watching, and God bless you.